Why do people go bald?
Why are baboons' bums red?
What's a light year? Why do leaves go brown in the autumn? Why do monkeys like bananas?
Why do some things glow in the dark?
Why do animals not understand humans? Why do my receipts fade after a year?
Don't know the answer? Ask the Naked Scientists.
Hello and welcome to this week's Ask the Naked Scientists with me, Atterley George, and with Dave Ansell. Ralph in Stamford says, "Hi Dave, what's the difference between an asteroid and a meteor?" Can you answer that one? I've put Dave completely on the spot here. I don't know if he needed any preparation time, but he certainly hasn't had any, so...
Okay, an asteroid is basically a lump of rock which is orbiting the sun. Mm-hmm. So a smallish lump of rock, anything up to 100 kilometres across, down to a few tens of metres across, orbiting the sun. While it's sitting there orbiting, it's an asteroid. A meteor is something which hits the Earth's atmosphere. When things which hit the Earth's atmosphere, as they fall towards the Earth, they get going incredibly fast. When they hit the gases in the atmosphere, they compress the gas. When you compress gas, it gets very hot. So you get this fiery trail of these really hot gases, and it evaporates, and you get all sorts of exciting things happening. And so you see a streak in the sky. So a meteor is stuff hitting the atmosphere. A meteorite is if it gets all the way down to Earth and you find a lump of rock on the ground.
OK, so meteor is whilst it's in the sky?
Yeah.
Does a meteor then become an asteroid as it enters the atmosphere?
And if an asteroid, or a very, very, very small asteroid, a little lump of asteroid which hits the atmosphere would then turn into a meteor.
Oh.
And if it's big enough to get to the ground, it's a meteorite.
Well done, Alan. No, it was Ralph. I beg your pardon. Well done. I had no idea. I just thought they were completely different things. That's amazing. Right, will there be a test afterwards? Because I probably won't be able to repeat that back to you. But that was amazing. Have you looked out for the Perseid?
I had a little bit of a look. I was out a couple of weeks ago, and someone else saw one.
I thought it was this week.
It's actually spread over about a whole month.
Okay.
What's happening is that the Earth is orbiting and moving through the trail of a comet called Swift-Tuttle, which orbits every 130 years, and its orbit passes through the Earth's orbit. So there's lots of dust and stuff which has been thrown off by this comet, which is just following the same orbit. And the Earth flies through all this dust. Some of the dust hits the Earth. It's going so fast, even just something like the size of a sand grain, it's releases enough energy to light up a little streak in the sky. Right. And the kind of cloud of dust and stuff is quite large, so the Earth slowly moves through it. This is just the brightest period when you get sort of 60 or so meteorites every hour. Yeah. But it's slowly building up, and it will slowly die away again over a month.
Because as I said, I had a bit of a sort of cursory look the other night at about 3 o'clock in the morning when I happened to be awake. Couldn't see anything. Wasn't very exciting. But I might have a look. Obviously, I'll be out and about tonight on my way home, so I'll have a little look then.
You want to get somewhere away from the street lighting?
Yeah, it's quite difficult where I live. Alan in Orpington. Hello, Alan. He says, we've got so many remote controls. I mean, I'm just thinking about, in my sitting room, there are probably... there's probably about 4 or 5 different remote controls for various TV, satellite decoder box, DVD player, blah, 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 blah. He says, how much space do we have left for all these signals before they interfere? I thought that was a great question.
It's a wonderful question, actually, yeah. The way normal remote controls work is basically Morse code with a flashing light. But they flash with a colour of light which you can't see. It's just beyond the red in the spectrum. There's a colour called infrared. And they flash in the infrared. If you point one at a mobile phone camera or something, you can actually see it flashing, because the camera on your mobile phone is sensitive to the infrared light. So you can see the light flashing.
Okay.
So it basically sits there, it flashes a light at your TV. Your TV's got a little sensor, it detects a light. The flashing is coded a bit like Morse code. Mm-hmm. Some of that code is to tell it what kind of remote control it's supposed to be. So the first bit of each code is going to say, I'm a Samsung 548971.
Hello, I am a Philips, yes.
Then the second half of the code is going to be turn on, turn off, change to channel 15 or whatever. So as long as they don't start overlapping with those codes, if you got one remote control is not going to start, your TV remote control is not going to start turning on stereo or whatever, as long as all the manufacturers talk to each other and use different codes.
Okay.
But if you have 2 of them if you had enough of them and all point them at your TV at once and press buttons at random, then the TV's going to get confused, because there's going to be flashing lights going off all over the place, and it will get confused.
So is it possible to, if you've got and I apologise if I'm asking you questions that is getting too deep in here, but if you've got, say, a television and a DVD player that are the same make, that says, hello, I'm a whatever, would sort of one Morse code signal from one remote be telling the DVD to do something else? Do you see what I mean? To do something else?
It entirely depends
dip,
how
dip, da, da might
Yeah.
mean turn on channel 1 on the television, but it might mean stop the DVD from playing.
If they organised it wrong,
Yeah.
if they weren't careful
They're
and they
doing it
didn't
wrong.
use different codes, then yes, that could
Because this all used to go, this was my story I was going to tell you. I remember having a television very clearly. In fact, it was quite posh at the time. And it had a remote that had 2 buttons on it. There was on
Yeah,
and change the channel. Okay?
yeah.
And they were just 2 very big buttons, and they worked on sound.
Oh, ultrasound or...
I'm not entirely... We're talking a long time ago. Okay?
Yeah.
And this television was in the kitchen, and if you actually were doing the washing up and you put the cutlery back in the cutlery drawer in the kitchen, the television would change channel. And didn't they drive pets mad or something?
Yeah, it would be ultrasound.
Yeah.
Again, it's using sound above 20 kilohertz, which you can't hear, but dogs and cats will be able to hear. Probably because the electronics were cheaper or easier at that time. And they'd be sending different tones or different codes.
But
in the
they'd
tones.
probably be banned now for being,
Cool.
unhealthy for the animals. So, Alan, great question. Thank you very much for that. Is that Janina? Janina? Apologies, but I'm not entirely sure. But I've had 3 goes at your name, so thank you anyway. Had a debate with a friend about parallel universes and if they could exist. And Janina says neither of us could understand how they could work. Any thoughts from you, Dave? How long have you got? I think
yeah. I mean,
we could talk about this till 10 o'clock tomorrow
I'm sure there's
morning.
certainly no actual answer to this. It's a very interesting
So,
question.
for those of us who are not, comfortable with the concept of a parallel universe, just in basic terms, what does that mean?
That's a good question itself.
Okay. Oh, God. I was trying to simplify things.
There's lots of different ideas of parallel universe. Basically, it's something like the universe which we can see with lots of stars in it, which we can't get to at the moment. So, however far we go in any direction in our universe, we're never going to get to this other universe.
Right.
There's various ideas of what these could be. One of them could be that our universe might be sort of like a bubble.
I know, I've heard that theory.
bubble.
My other half's very into things like this, and he made me watch a programme the other day that was all about that and about how we were, the space round us was a bubble, and then there could be other bubbles around.
So essentially, if you imagine sort of a bubble where you got the surface is 2 dimensions inside a 3-dimensional sort of room. Then our universe could be a 3-dimensional surface in a 4-dimensional room. So instead of up, down, forwards and backwards, up and left and right, you'd have another 2 directions. You can't imagine it because our brains aren't built that way.
No, we don't know. We just don't know, do we?
So there could be just sort of other bubbles of universes.
Because also we
around the
don't know
place.
how big we are, do we?
We don't really know how big the universe is.
I know I'm 5'7", but I don't know how big that is in comparison to the other big beings that could be out there. I mean, we could be one of their molecules, couldn't we?
Yeah, I mean, we can't see
have no
beyond.
idea.
The science can't
If a
go
big
beyond what we
hand
can
comes
see.
down one day and plucks the Earth, then we'll know that there's something
something
bigger.
more interesting.
Yeah.
Then we can study that, and it'll be fascinating.
So these concepts of parallel universes, then. So there's the bubble idea.
There's one, and the other big one is to do with the quantum mechanics. Because with quantum mechanics, basically, it seems that everything seems to work on probabilities. So if you have like an atom, it might decay. It might uranium. It might decay into thorium in every 10 years, and there's a 50%, maybe say a 50% chance of that happening. And we have no idea reason why possibly it might decay or might not decay, but we know it happens very accurately. There's a 50% chance of it decaying. And so one of the explanations for this is that every possible occurrence happens, and the universe kind of keeps splitting up into more and more possible things. And if you happen to be in this universe, you don't know about all the other infinite number of other universes with every other possible thing which could ever have happened in them because you're in this one. I mean, it's called the parallel worlds.
I think this keeps a lot of people very, very busy, doesn't it? I can tell.
There's a lot of very clever people who spend probably too long thinking about these kind of things. It makes my head hurt.
Do you think we've answered Januna's question? I don't
know if
it's
we've
the
answered
kind
it,
of
but I
thing
think
that you'll never ever.
Yeah.
Well, unless, as we say, unless the big hand comes down.
Or we find some way of seeing the big hand by some interesting
We'll just never
experiment.
know. But it's good.
I mean, there's all sorts of scientists who think that possibly, if there are other universes, are looking at ways, if the bubbles kind of universe, ways of possibly seeing how they might interact with our universe, or might have interacted when the universe was older, and all sorts of.
Well, as long as they don't bounce into each other and crash, then that's good, isn't it? Tony is on the line. This one here, I think. Tony, good evening to you.
Good evening to you, E.T.
I'm used to saying afternoon to people.
I know.
Now, whereabouts are you, Tony?
Westcliff.
Okay, very, very good evening, and welcome to the programme. What's your question for Dave?
Right. Good evening, Dave.
Evening, Tony.
It's just that it seems to me that all garden electrics, hedge cutters, etc., only have a positive and negative lead going from them to the plug. Whereas everything else in the house, for example, have an earth lead. I wondered if there's any reason for this.
I don't know. I've never really looked. I think my lawnmower has an earth lead. I know not everything legally has to have an earth lead. If all of the electrics are under they're what's called double insulated, so they're under 2 layers of plastic.
That's it, probably.
Then I think they assume that it's unlikely that you're going to break both layers of plastic without noticing and turning the machine off. So things like the little power bricks which you plug into the wall, and a lot of small electrical plasticky equipment don't have earth leads, because everything is well enough insulated. Everyone decides that you're not going to break it. You're not going to break it in one go badly enough to be able to get at the mains inside. I'm surprised that maybe hedge trimmers are just covered with enough plastic that.
Well, I'll just say that I've cut through it at least twice. It's never done me any harm.
Listen, if you've cut through the lead twice, Tony, I suggest it's time to get a new one, wouldn't you, David?
I did get a new one, but it's too heavy. I can't carry it anymore. Getting too blooming old.
Get someone in. That's a better idea.
Yeah, the wife.
Tony, fantastic. Has Dave answered your question admirably?
I think so, yes. It's one of these funny old things, but...
Yeah.
Here we are.
Marvellous. Excellent.
Very kind of him. Thank you, Dave.
Thanks, Tony.
Thank you, Tony. You do take care.
Bye.
So bye-bye, Tony there from Westcliff. Just wanted to talk about an artificial brain.
Oh, yes.
There was a story in the news. Now, this story has been around in the science world for a few weeks. Well, probably even longer than that. But I noticed today on the internet that it's been kicking around for at least a couple of weeks. But I saw it in the paper, I think it was yesterday or the day before. And in Switzerland, there are people, well, there are probably other people doing it as well, but basically they're trying to construct a fully functioning artificial brain. I mean, my brain boggles at the thought. And you've investigated this a bit further, haven't you?
Yeah, this is a guy, there's a guy called Henry Markram. He sort of seems to be in charge of the project. He's giving a talk, one of the TED lectures, which are fascinating things. If you ever Google TED lectures, if you want to waste an evening. Because there's all sorts of fascinating, very interesting people.
Instead of me falling asleep on the sofa, which I normally do, I should be Googling TED lectures.
You Google the TED lectures, you've got all sorts of interesting people talking about interesting things. Anyway, he's based in Switzerland, and basically he's head or involved in a big project called the Blue Brain Project, where basically the idea is that everyone's studying bits of brains and bits of neurons and trying to work out how they work. And the reason why that would be useful is if we could build a model of it. So you can then, in the short term, you can build models of bits of the brain. You can then see what happens if you put a drug into it or something, and see whether that's likely to have a bad effect or a good effect, and sort of start to understand how the brain works. So they've been spending the last 15 years so far looking into rats' brains, looking in very small scale, sort of measuring electric currents, and if they prod it here with one set of electric currents, what comes out the other end. And they reckon that each neuron in the brain, for them to model it properly, needs about the processing power of a laptop. And there's about 50 or 100 billion neurons in a brain. So I think if they're going to be able to build a whole model of the brain just on computing power, they're going to have to hope that computers keep getting quite a lot faster.
I mean, basically, if this is to form part of a robot, ultimately, at the moment, it's going to be about the size of the big hand that we were talking about before, isn't it?
Yes, pretty much. I think that basically they're not really wanting it for the robot. They really he wants to study it so as we understand human brains better, so we can understand when they go wrong better and how to mend them. And sort of understand things like Alzheimer's, all the problems with the brain, because I mean we understand how heart works. It's a pump. We have no idea how the brain works.
And he reckons that this is going to be ready in 10 years' time.
Yeah, I mean, it sounds quite optimistic to me. It feels like the sort of thing which is going to be more difficult than you think.
Sounds like you might have one cell ready. I mean, for goodness sake.
I mean, he's going to have... I could imagine that he's going to have models of sort of fairly large lump bits of brain in that time.
Yeah.
I mean, I think he has built a model of, I think, half a rat brain or something. Right. I can imagine he'll have a model which will show quite a lot of the properties of a brain, but whether it will be the same as a human brain, I have a feeling there's lots of subtleties in there.
Now, I know that this has then raised some quite interesting ethical questions about a bit that, you know, it's kind of Frankenstein question of, if you turn this thing on, if you switch it on, what actual crime are you committing to switch it off again? Yeah,
it's a fascinating one, that, because I mean, if you have built an accurate model of a brain and you're running it, then that's essentially the same as a human brain.
Does it have human rights?
I think that's a question for the lawyers and the ethicists, not me, I'm afraid.
And I'm sure people like Isaac Asimov, they foresaw all this, didn't they? You know, they saw that coming.
Yeah, I mean, the science fiction, it's the sort of thing which science fiction writers have been predicting for a long time.
Yeah.
If not, there's some things which they get and some things they won't. But yeah, I mean, I think it's going to take a while to get. I think it's going to be a long time till we reach that ethical question.
Fantastic. But let's meet Alan first of all. Alan, good evening to you.
Yes, good evening.
Hi, whereabouts are you from, Alan?
Orpington in Kent.
Okay, and you have a question about electricity and batteries.
Yes, well, basically we are heading towards a time where we're trying to get cars to run on batteries to save, obviously, fuel and to become more green-friendly. Now, some time ago, it must have been over 30 years ago, I actually tested a vehicle, and the battery in it weighed a third of a tonne.
Yeah.
Because they said that they couldn't get more than 1.5 volts per cell. I was wondering what's happened since then to enable vehicles to get that level of power into them, but either become smaller or... Well, what's just happened? I just don't understand what's happened since then.
Okay, basically, batteries have got a lot better. You're right, the cells used to be... Actually, it depends on the kind of battery. You have 1.5 volts from something like a NiCad battery, nickel-cadmium battery, slightly more, I think, from a lead-acid battery. A lot of batteries these days are lithium-ion batteries, which are about 3 volts per cell. But that doesn't really matter, because you can always get more voltage by putting in more smaller cells. The really important thing is about the amount of energy you can squeeze into a cell. And basically, partly because everyone's been trying really, really hard to get more and more energy into things, for things like mobile phones and laptops. Especially these lithium-ion batteries have got much, much denser. You can get probably at least 10 times as much energy for the same weight as a lead-acid battery. So basically, you can get far more energy in for the same weight, so the car's a lot more practical. Although it's still nothing compared to petrol. Petrol's the most ridiculously, incredibly efficient way of storing energy.
Yeah, so what about the fact that they slowly reduce in value, the battery, slowly reduces in value as you use it? How on earth do they sort of maintain the same level of speed when you first go out in it to when you're coming back home in it, sort of thing?
As the battery discharges, it's got less voltage. I mean, some of it is that some different battery chemistries aren't as bad for that. And the other thing is basically you can use clever electronics to convert voltage from whatever the voltage is to your battery to whatever the voltage your motors need, without just quite efficiently, sort of over 95% efficiency. So even if your batteries are almost flat, you can convert that voltage by taking more current to 100 volts, whatever your car motors need. So it doesn't really matter. Yeah.
So is there a possibility that you could get to a point where it would just cut out?
Yes. If your battery goes flat, then if there's no energy left in the battery, then you're not going to be able to go anywhere. I mean, the range is the big problem with electric cars.
This is the thing, you see, because I can remember only being able to do about 75 miles on this massive battery. and then we was limited to about 30 miles an hour.
Yeah, I mean, it's definitely a lot better than that. They're over 100 miles, cut some of them up to a couple hundred miles, but yeah, it's a problem, and they're still working on it, and batteries aren't perfect.
Alan, thank you very much for posing the question. Our thanks to Annie in Peterborough. I had a similar question as well about electric cabs rather than diesel cabs, because obviously if you're staying within a town centre or city centre, then
I mean, I think
probably a good idea.
Yeah, I mean, if you've got somewhere to recharge and you can recharge, the problem with the cab is it keeps driving for a long time.
Yeah.
I think delivery vans are definitely
time's money.
about
You don't want to be stopping, do you? You do not want to be stopping. We've had a question, Dave, about wormholes. Now, I don't think they mean the sort of, that you get in the ground early in the morning when the early bird catches the worm. I think they mean sort of time slippy type wormholes, the things that you can drop through and probably end up in your parallel universe. Now, Kevin in Welwyn Garden City says, some years ago, we thought we jumped through time. We somehow managed to travel from Bedfordshire to Welwyn Garden City in 15 minutes, usually the best part of an hour. I'm sure there's a more down-to-earth explanation for that.
Yeah, I would have said that it's much more likely that something fairly down-to-earth happens. I know
your battery went flat.
Possibly,
clock, maybe,
your clock might be going slow. I mean, people have hypothesised things like wormholes, but all of the... If the universe works the way we think it does, they involve incredibly very large masses, incredibly dense.
And you probably get squished if you went through one.
Yeah, I mean, if there'd been a wormhole somewhere near the Earth of any size which you could walk through, then we'd know about it, and there'd be huge holes. Whether the Earth would still exist, I don't know. I think it's probably, you do get strange things with the way your brain works, that quite often sometimes you end up driving on entirely automatic, and you don't remember the last 250 miles you've driven along, because your sort of conscious brain isn't really paying attention, and your subconscious brain is still it's quite scary. I think if that happened and your clock was a bit on the blink, I think that's probably more likely
than the wormhole scenario.
Yeah.
Okay. Kevin, thanks very much for that. Nigel in Milton Keynes has got a sort of related question, because in that it's to do with space and planets and things. My question is about Saturn's rings. There are moons in them. Is the ring... I don't know if you could answer this off the top of your head, but is the ring debris... We do put him on the spot, don't we? Is the ring debris forming other moons, or essentially trapped? Does that make sense to you?
Yes. I think there's definitely evidence that it's more likely to be something around the other way around. The moons seem to sort of herd the rings. So quite often you'll get a moon with a ring either side, or a ring with a gap. There'll be gaps. If you've got a whole lot of... Saturn's got lots of moons.
Right.
And there's lots of
rings.
The rings are made up of lots of kind of dust and rocks and stuff. And in between, and the moons aren't very rarely inside a ring. I don't think they're ever inside an actual ring. They tend to be in the gaps between the rings, definitely the big ones. And the gravity of the moons tends to kind of either keep the ring slow down any rocks which come out too fast, or can move down towards the moon and they get sped up. And if they move out, basically they kind of shepherd the rings and keep them much more...
So each one has got its own force kind of thing,
the gravity of the moons keep the rings in the right shape. Some of the rings definitely on Jupiter are created by moons, volcanic eruptions from the moons. I think some of the Saturn's moons get sort of water volcanic eruptions, and they form particles which then make up moons. The rings could also be made by things hitting moons, and you get a load of debris thrown off, and that could form a ring.
So basically, I think this is what Nigel is getting at, that the dust that is floating around is not necessarily making new moons. It's kind of suspended dust that's being held.
There's not enough
these...
there to be forming moons. Yeah. I think, and it's very cold and it's moving quite fast. So I think the dust tends to be breaking the moons apart rather than gluing them together.
Okay, brilliant. Now, Nigel, thank you for your question. Phil says, this is something completely different. How does an automatic weather station gauge visibility for the shipping forecast?
It doesn't quite do it the same way as your eye would do. I think
because we'd get some binoculars,
we'd look at something, and we'd know it's about 3 miles away, and we can only just see it. So visibility is about 3 miles away.
Or you get your mate to run off keep running
with a big long tape measure.
Yes,
Probably
something like that.
A less practical way of doing it, but it would work too. and you estimate it. I think the way automatic weather stations do it tends to be they, say, have a reasonable bit of air, sort of 50 metres or something. They shine a laser from one end through the air to a mirror and back again. They have a detector at each end, and they measure how much light makes that journey.
Okay.
And if there's lots of mist there, then a lot of the light's going to get bounced off somewhere else, so the light can't travel very far. So
that's how pure the signal is on the way back.
Yeah. So basically, how clean the air is. So it's probably measuring much more locally than you would do, because if there's a big sort of fog bank coming in, then you'd say the visibility was less because you can't see beyond the fog bank. But until the fog bank got to the sensor, it wouldn't know about it.
Yeah. Cool. Fantastic. Thank you very much for that. Somebody has, I think, texted saying, I've had a catheter fitted. Why do you pass more fluid in the day than in the night? Now, my first obvious and probably ridiculous answer to that would be because you're drinking more. Obviously, if you're not drinking, if you're not putting in, it's not going to come out, is it?
That will be some of it, certainly. Probably Chris is the best person to answer this.
Yeah,
know all the names of everything.
Yeah.
But when you're asleep, you give out a special hormone which actually stops you producing urine or reduces the rate at which you produce urine. So fluid will sort of build up in all your other tissues. It's so as you can keep sleeping for 8 hours without having to go to the loo.
I never knew that.
So you don't make as much urine, so you don't need to last for longer without having to go to the loo.
Look, I'm learning stuff. Now, we have somebody called Alejandro, I hope I've pronounced the name correctly, who says, as I understand it, white surfaces reflect all frequencies of visible light. Isn't that what mirrors do? So basically, what is the difference then between a mirror and a white surface? Can you put that question into words of one syllable that I can understand, first of all?
Well, basically, the reason things look white is because all of the colours of the rainbow from the light or the sun bounce off them into your eyes. So your eyes see a mixture of all the colours of the rainbow, which you see as white. A mirror reflects...
So this white piece of paper is not actually white?
It's the light bouncing off it is a mixture of all the colours of the rainbow, and your eyes see that as white, or...
Okay.
Right. And a mirror, all the colours of the rainbow bounce off a mirror as well.
Yep.
So he's asking, what's the difference between the two?
Okay.
The simple answer is kind of how smooth they are. If you get a mirror and smash it up into lots of pieces, then you'll see lots of tiny, tiny images. They'll be made up of all the colours of the rainbow as well. And if you smash those up into smaller and smaller and smaller until you can't see individual images, then it will look white because...
You see, now I want to go home and smash something now. I'm tempted to go home and smash something.
It's the same thing. If you look at a little crystal of salt, if you look at one of them very individually, they're transparent and it looks clear like a piece of glass. But because light, when it hits it, it bends and reflects off it. If you ground it up and look at it from a long way away, then it looks white because all the colours of light are bouncing off it in random directions. So you can't see the images anymore. Everything's mixed up and it looks white.
Well, I never... So. Now, okay, so I can turn the see-through bit of salt into something white. Can I turn this piece of paper into a mirror?
Not easily. You have to make it very, very flat.
Answer. Dave, we thank you for your time. Thank you so much for joining us. That's it for this week. Our doctors will be back next week for more Ask the Naked Scientists. But don't forget, you can also catch them on the Naked Scientists podcast, which you can find on the Naked Scientists website, www.thenakedscientists.com.
The Naked Scientists are sponsored by the Wellcome Trust, the EPSRC and UK Fast. For more information, look us up online at nakedscientists.com.